So we're not looking at the multiple choice this evening. We're looking at various questions, as you could see here. I'm actually starting off with a coordinate geometry question. All right, so I'm going to work. Let's go. So the question says P, which is 6, 1. So let me just write this here. P, which is 6, -1, and Q, which is 2, 7, are endpoints of a line segment PQ. So yeah, we have the line segment PQ, and there would be P, and there would be Q. All right, no problem. Determine the gradient PQ. All right, so we want to know what is the slope of this line. Now, questions like these normally come a lot of times, all right? So these questions, they always come. So what we want to do, though, is label our points. Every time I see them, the first thing I'll do is to label my points. So I am going to label my points. I'm going to call the first one X1, and then X1 walk with Y1. Then the next point, I'll call it X2, and X2 walk with Y2. Some persons might be asking, like, which one is X1 and Y1? Well, anyone. So just make sure that X1 walks with Y1 and X2 walks with Y2. The basic idea, though, is that a coordinate will always have the X value comes first, then a Y value. That is it. X value is first, then the Y value. Now, what is the gradient? Remember the formula for the gradient. And we don't get this formula from CXC. So we're going to have to know this. It says the change in Y, which is Y2 minus Y1 over X2 minus X1. A lot of people tend to know this formula. So if we have this formula down, then we can easily substitute what we just wrote. So Y2 is 7 minus Y1, which is not 1, it's a -1. So I have to be very careful, -1 all over X2, which is 2, minus X1, which is 6. And then we want to put everything together right there. So remember, though, when we have two signs like these clashing, it becomes a plus. So we're looking at 7 plus 1, that's an 8 on top. And then we have 2 minus 6 will give us a -4. So basically 8 divided by -4 will give us a gradient of -2. So you'll say 2 over 1, which is basically saying a -2. So the gradient of the line PQ is -2. All right, is -2. All right, guys. All right, so there it is. So I still want you to work. And if you find your answers, you still could put your answers in the chat. Whatever questions you have, you could drop them in the live chat and stuff like that. All right, so that's the first question. We found the gradient, and the gradient was -2. All right, so let's go. So we have -2 right there. The next question says the coordinate of the midpoint of PQ. Now remember, so in order to do the coordinate, we really need back the points system that we have here. So it's 6, -1, 2, 7. All right. So make sure I'm not making any error there. So let me write it there. Talking about 6, -1, and then we have a 2, 7. All right. So those are the points that we're dealing with. Let me make sure. Yes, it is. All right. So for the midpoint, the labeling is the same. So we keep our labels X1, Y1, X2, Y2. But definitely we have to know what is the formula for the midpoint. All right. What is the formula for the midpoint? So we have to be on our P's and our Q's. The formula for the midpoint says this. We have X1 plus X2 over 2, because it's going to be a coordinate. So this is going to provide us with the X value, and there's a comma, and then we have Y1 plus Y2 over 2, and then we have a comma. So this is the formula. You do not get this either from CXC. There's no coordinate geometry formula that you will get from CXC. So definitely for the paper 2, you would have to have certain formulas done for yourself. So again, this one says x1 plus x2 over 2, y1 plus y2 over 2. So we're going to do our substitution right now. For example, so we're saying x1 is 6. So we're having 6 plus x2, which is 2 all over 2, comma, and then we have y1, which is -1, plus y2, which is 7 all over 2. And then we do this. I'm just going to put it up top up here, all right? So we're saying that 6 plus 2, that is 8 over 2. That's my first x. And then -1 plus 7, that's positive 6 over 2. Final response, 8 divided by 2, that is 4. 6 divided by 2, that is 3. So the coordinate of the midpoint, so this is the midpoint coordinate that we have just found. All right, those are the coordinates for the midpoint. That's our x and that is our y. And that's the response that they're looking for to give you 2 marks right there. So technically it's just having the formula and that's it basically. All right, so the next question now says that the equation of the perpendicular bisector, and this is a very interesting thing. So let me just drop 2 lines here. So let us say we have one line like this. Our gradient was negative, so I'm going red line for PQ. All right, so I'm dropping my PQ here. So I'm just saying, let us say this is P and that is Q. All right, and then there is another line now that we are being told that is a perpendicular bisector. And what a perpendicular bisector means is that that line is gonna cross the other line at right angle. All right, so it is saying that the equation of a perpendicular bisector, and not only just at the right angle, it's gonna cross like in the middle. So I'm trying to find a middle, like kind of like the middle. So all right, so let us say I'm saying that that's the middle. So a perpendicular bisector, the word bisect means middle, and perpendicular means 90 degrees. So English-wise, if we apply our knowledge of the language of English, this is referring to a 90 degrees, and this would say mid, like middle. So we're saying then that the midpoint, now you could see the connection for a midpoint here, because if this blue line is going to pass, it's going to pass through at 90 degrees here. That's what they're saying. That's a 90 degree. And not only that, it's passing at the midpoint, but we just found the coordinate for the midpoint because middle. So this midpoint is a 4-3 from the previous question. So I'm suggesting to us that, hey, we have a coordinate for a point that the line passes through. Right there, it is 4-3 for the midpoint. That's our x and that is our y. So then, of course, they could ask us to find the equation of this line, because in order to write an equation of a line, we definitely need 2 things. We need 1, a point that it passes through, and 2, we need the gradient. Now, definitely, you can see for yourself that where they meet is the middle of the line based on the meaning of the words. And then we automatically found out that we had the coordinate for the midpoint already. So what we're going to do now is to, how do we get the gradient? Because I need a point and a gradient to come up with the equation of a line. So then there is a relationship between perpendicular lines, right? So it is said, if I just push this to the side a little bit, it is said that when 2 lines are perpendicular, right? So when we have perpendicular lines, one gradient is the negative reciprocal of the other. So the gradient for PQ, this is P, so the gradient, let me just write the word gradient. So we're talking about gradient PQ was -1/2. So a perpendicular bisector, I'm just going to use the word bisector here. So the bisector's gradient would be this. And let me put, you know what, let me put perpendicular. All right. All right. So we're talking about the perpendicular bisector's gradient is going to be the negative reciprocal. So you turn it upside down and change the sign of the entire thing. For those of us who think that it is just a 2 that is the negative here, 2 over 1, it's fine. Everything is negative. It's just a negative number. So when we find the negative reciprocal of it, which is going to be this, we're suggesting to you it is going to be a positive number. All right. And that's what we have right there. So then, looking at this right here, looking at this right now, we're saying that we have the gradient for the bisector. It is going to be positive 1/2. So we could put it together. So let's just write it right here. We have a gradient which is equal to positive 1/2. And we definitely have a point which is 4, 3. So we can use these to create the equation of a line. We can do this more than one ways though. So I'm not going to say that we have to do it this way. We can do this like more than one ways, right? So we can do that more than one ways. So in an effort to do it more than one ways, I'm going to say to us that we could find C and work it, or we could just use what is called a point slope form. The point slope form says y minus y1 is equal to the gradient m, open bracket, x minus x1. So this is what we call the point slope form. Now, if we have this, then we can definitely just get to our equation now. So let us just label our points. We could call that x1 and y1 to suit this situation. So let me shift a little bit to the side so that we could put the working out there. Let me put this down here. So I'm going to put the working out here. So let us look on the working on the side here. So the gradient, which is m, is equal to positive 1/2, right? And the point that we have to work with is 4, 3. I am calling this x1. I'm calling that y1. When we have a gradient and a point, we could employ what is called the point slope form, and it looks like this. It says y minus y1 equal to m, open bracket, x minus x1. What we're going to do is to substitute y minus y1, which is 3, is equal to m, which is positive 1/2, open bracket, x minus x1, which is 4. So we have simply substituted everything here. Everything here we have just substituted in the point slope format right there. So now that we have done that, we can now just carry out our algebra. So let's take our time, carry out our algebra. I'm going to write back y minus 3. And this is going to equal to me distributing this half inside. So 1/2 x. And then you could say 1/2 of 4 is -2. But I'm going to write the half beside the 4, and let us cancel that down, and then you will see that this into itself 1 and that into that 2, you're seeing your -2. So let's go forward. Y minus 3 is equal to 1/2 x minus 2. We're almost done. We're going to add 3 to both sides. Watch. To get rid of that 3, get rid of that 3. So we're done. So let me just relax and put this to the final. So it's going to be y is equal to 1/2 x. -2 and a positive 3 give a positive 1. And there we are. We're done. This is the equation of the perpendicular bisector. I'm not rushing off because I want us to really understand the concept here. The concept here is that perpendicular bisector would suggest that the line had passed through the middle of the line. Hence, that was the reason why they allowed us to find the midpoint before. So you could see why they would have said, find the midpoint. So we found the midpoint, right? And definitely using that midpoint, we use it with the gradient. And there is a relationship with perpendicular lines, lines that meet at 90 degrees. One of them gradient is the negative reciprocal. Or people say the negative flip upside down of the other one. All right. So then you utilize that and solve your thing right through. All right, is that okay? Anybody just want to say yes, no? You can type in the comment if you're fine. If there's something you want me to repeat, you could drop it in the comment. I'm always looking, right? I'm always looking to assist. All right, so the equation of the perpendicular bisector of PQ is y equal to half x plus 1. Very straightforward there. All right, as I said to us, we have mixed questions. Okay, Otavia, seeing your response. Very good. All right, so now we have this question. So this is a trigonometry question, right? As I said to you, I'm looking at various questions all over the paper. All right, so it's not like I'm looking at number one. I'm looking at any question. All right, so it says on the diagram below, not drawn to scale, TU equals 8, and we're seeing that it's there. It says that TV is 10, it is on the diagram. VW is 11 meters, and angle UTW is 60 degrees, and the angle WUV is 40 degrees. So every single thing that they just gave us here in the instruction, it is actually on the diagram, which is excellent, which is very good. So now, let us see the way forward. Calculate the length of UV, right? Calculate the length of UV. Calculate the length of UV. All right. All right. Okay, calculate the length of UV. So let us mark that point UW. We're supposed to find UW, and UW is this line. So we want to find that line there, right there. All right.
Sir, I have a question.
Go ahead.
Sir, at the one that you just did, at number 11, I think.
All right.
Sir.
All right. Go ahead, I'm listening.
Sir, go up more over to the block section. Yes. Sir, the section where you have y minus 3 equals a half x with the negative a half with the open bracket.
It's not negative a half, you know, it's positive a half.
So, sir. So why you have a negative in front of the one?
Where?
Sir, right?
No, man, it's not negative a half. Where you get negative a half from?
Sir, me see I have one negative a half right there.
Come on, look for yourself. The gradient is a half.
Okay, sir. 1, 2, 3 for the fourth row.
Yeah, man, there is no negative in front of anything. I'm not seeing negative, so maybe it's what you're looking at, but there's no negative in front of it. It's positive a half that was used.
Okay, sir.
And the numbers were correct, because negative a half times x is just half x.
Sir, you see where it is though?
No, I'm not seeing any negative. Right here you're talking, there's no negative there.
No, sir, not the other one beside it.
Yes, there's no negative there.
Okay, sir.
The negative 2 was there, and the negative 2 is to be there because we have a minus 4 at the back, right? So I'm not sure what you're seeing, but remember, this is the answer, and look at the answer. You'll see that there was no negative there. The reason why we get a positive 1 at the end is because negative 2 and a positive 3 gave a positive 1 at the end, but there was a negative 2 at the back until there was a 3 being added to it. Good? It's fine, man.
Okay, sir.
All right, good. All right, so we were looking at this here. All right, just was clarifying something there. All right, so we're looking at this here. So we're saying that we want to find UV. Somebody said the sine rule. I would say look again. You're going to use the cosine rule, you mean, all right? So remember though, when you know everything in a corner, for example, when you know everything in this corner right here, we're having the sides and we're having the angle. and you're trying to find the side across from that angle, then it's going to be the cosine rule every single time. All right. So now let's look at the cosine rule. The cosine rule says the side across from the angle. That means this angle, this side that we intend to find. We start off with it, this side, and it says WU square is equal to, and now we're going to be using the sides 8 square plus 10 square minus 2 times 8, that's my times in bracket, times 10, and that is going to be multiplied by the cosine of 60 degrees. So this formula should take us out to the end. This formula should take us out to the end. Yes, angle between two known sides. Very good. So we're suggesting now, let me take my time. So this is going to be 8. We're talking about 64. This is going to be 100. And then we're going to put all of those on the calculator. So anybody working with me there, -2 times 8 times 10. And then that is going to be multiplied by the cosine of 60. Make sure that the calculator is in degree. All right. And that looks like about -80. I want somebody to confirm with me. Yes, I think it is correct. So that's a -80. So finally, we'll get in there. So UW square is equal to 64 plus 100. That's 164 minus 80. That is 84. So it's a root of 84. So let's take the root of both sides. So UW is going to give us root of 84, and that is 9 points. So we have 9.17 to 3 significant figures. All right. So we have 9.165, approximately 9.17, since there was no specific instruction. So our answer is 9.17 meters there. All right. Very good. Everybody good with that? Yeah. Good with that? Okay. All right, good. All right, so that's what we just found. What I'm going to do is to label, though, I'm going to label that side that we just found. So we just found this to be 9.17. All right, let's look at the next question. So right now we have a 9.17 meters for that right there, going up. So we're saying that the size of the angle UVW, mark the angle. I'm going to mark the angle in blue. So we said UVW, which is going to be this angle right there. So we're saying, what is the value of that angle right here in yellow that I marked blue right there, right? So that is the angle that we intend to find right now. Remember, using 3 letters, the angle is always in the middle, all right? So then we are saying that, guess what? If you're looking, if anybody is looking, we could jump at the sine rule now, because guess what? We are seeing that we have an angle and a side opposite to it. They ask us to find an angle, and then we have found the side opposite to it. So whenever you're finding a side and angles, or angles and opposite sides in the mix, then the sine rule is what will take you out in any question like that. So I'm going to just shift a little bit to the side, and then we're going to do that angle up there. So let's go for that sine rule. The sine rule is a concept that says A over the sine of big A is equal to the side B over the sine of the angle at B is equal to C over the sine of the angle at C. All right. So that's the idea that we're going with right now. But we only need 2 pairs, like a known angle and the side opposite to it. And then we could use any one from the other and then go forward. So let's go. We're talking 11 over the sine of 40. Look at my arrows that I have in green. 11 over the sine of 40 is equal to 9.17 over the sine of the angle.
Mosquito bite me and me move my foot, can me think.
All right.
Me never know say a mosquito. You see him in front of your mommy. He might go outside.
So what we want to do here, is to employ a little cross multiplication where the sine of the angle times 11 is going to equal to the sine of 40 times 9.17. We know that, so we're going to employ that cross multiplication right about now. So 11 sine of the angle times sine of the angle is going to equal to 9.17 times a sine of 40 degrees. And you could see that sine of the angle would mean that, because this is 11 being multiplied by it. So what I need to do is, guess what? I just need to divide both sides by 11 right there. So if I divide by 11 right there, then we are seeing now sine of the angle that I intend to find is to put all of this together on my calculator right about now, and then we'll get the sine of the angle. That's not the angle, but it's going to be sine of the angle. So we're talking 9.17 times the sine of 40, yes, and then divide that by 11, all right? So I need about 4 dp, 3 to 4 dp, I'll take 4. So it's 0.5359. So I want somebody to just verify 5389, all right? Let me write it properly. 0.53, oh, 5359, good. 5359. All right, good. So then we're suggesting that this is not the answer. This is the sine of the angle. So whenever we're trying to find the angle, remember we always have to take the inverse. So it is sine inverse of 0.5359. And it's going to tell us the angle. I'm going to write out what I'm doing now. The angle at UVW. That angle right there. So let's do our sine inverse and we're good. Sine inverse of 0.5359 and we get 32.4. So I did get this angle is equal to 32.4 degrees. So this is 32.4 degrees. All right. All right, 32.4. All right, excellent, Chad. I see your answer there. Very good, Chad. All right, so as you could see, you know, employing what we have, we would have collected 4 easy marks right there. Just going through the ideas, we would have gotten those marks right there. All right. All right, so we are going forward now for the next question of the day. Next question of the day, we're going for it. All right, so the next question says that the area, and this is something that I've seen a lot, the area of this triangle TUW. So I could put it, I could just do a quick shade for us, maybe just another color. Let me go large with that. So I'll go with that. So we're talking about the area of this triangle right here. That's this. Area of that triangle. We want to find that area of this triangle here. All right. There's a very easy way to find the area of this triangle using trigonometry, right? Because in trigs, we're saying that if I have an angle between 2 sides, there is a special trigonometric way of getting the area of that triangle. So as you could see, we're going for the area of this triangle right there. So let's just get it. Let's get it. If you notice, we have 8, we have the 60, and we have the 10. So we have an angle between 2 sides. Whenever you see that, just know that you can find the area of that triangle very, very, very easily. All right, so we could do that. So then it's going to be area of this. I'm going to put the equal sign beside it. It's going to be half 8 times 10 times the sine of the angle that is there. And this will just take you straight out there. So in trigonometry, there is a way to find the area of triangles if there is an angle between 2 known sides. So the only thing, no mistake. So we're talking about a half times 8 times 10, that's about 40, times the sine of 60. And then it takes us right back down to 34.6 to 3 significant figures, and it's going to be square meters. So this is okay. 34.6, 3 significant figures is fine. Remember that when they don't tell you what to do, 3 significant figures is like one of those default rounding off that you can do for them, right? All right, very good, very good, very good. 34.6. I'm looking to see if anybody had come up with that as yet, just before moving on, just for verification. All right. Looking forward for a verified answer right there. All right. All right. All right. Good, good, good. Excellent working, Lopez. I see you pushing out. Very good. Very good. All right. All right. So here we have now other questions. As I said to you, I have scattered questions. Questions all over the paper. So this question came at number 2, and it says this. It says, guess what? It says solve, right? It says solve this equation here, but it's a regular linear equation. So I'm gonna rewrite it right here. So it says p plus 5 minus 7 equal 4p. So there it is. There it is, equal 4p. So in this case, what we want to do is simply distribute the 2 inside, because we want to find a value for p, but we could see that the p is trapped inside the bracket. So we're going to have to distribute the 2 there, distribute the 2 there, clear the bracket, and then start putting things together. So we're looking at 2 times p, which is 2p, 2 times 5, which is 10, and then minus 7 equal to 4p, right? So we're going there. 4p. All right. Now, let's just rewrite this. So this is 2p. 10 minus 7 is a positive 3, and this is equal to 4p right there. So, all right. So 2p plus 3 is equal to 4p. Gathering our p's on one side. So because I have a p already over here on this right side, what I'm going to do, I'm going to subtract p from the left side, the 2p, and subtract 2p from that side for balancing. So on my left side, I'm left with a 3, which is now equal to 2p. So 3 is equal to 2p. Then dividing both sides by 2, I could say that p is equal to 3 over 2. Some people might say 1.5. And we would have collected 2 marks there. So p is equal to 1.5. All right, 1.5. All right. All right, Chad, I'm not sure you got 6. Not sure you got 6 there, Chad. Not sure you got 6, but I guess you will see where any error that was made, you would have probably picked it up by now. All right. All right, let's go. Let's go. Let's go. Let's go. All right. So we have so the next question is a factorization question. So we're going to be factorizing now. So it says factorize completely. Factorize completely. And this factorization, let me kind of put it to the right. So it says factorize completely, and we're looking at 25m squared minus 1. The moment you look at this though, we're looking at, yes, El Cisco. The moment we're looking at this, we're looking at the difference of 2 square. Exactly, exactly. So the difference of 2 square. So what we want to do is just to find out where they're coming from. So we could say this is coming from a 5m that was squared, and this is coming from a 1 that was squared. If you want to do that, not saying that you have to, but you know, just to say. Therefore, we're going to have a bracket here for that and a bracket here for this. So it's going to be a 5m and a 1, and then it's going to be a 5m again and a 1. Then we'll put a plus in front, and then we'll put a minus, and there we are. We're done. So completing the square here, we'll have a 5m plus 1, and then a 5m minus 1, and we're finished. Or you could say 5m minus 1 first, and then the 5m plus 1 after. That is perfectly good to go. All right. All right. All right. So I'm going to do the other one right beneath. So right below this one, I'm going to be dropping 2n squared minus 3n minus 20, right? So we were asked to factorize this, all right? So in factorizing this, you could see that there is nothing in common. It's not the difference of 2 squared. It's not factorization by grouping, but this one can be done by the AC method. But the purpose of the AC method is to find two numbers to actually take the place of the middle, here, so that we can add 4 numbers after that to factorize by grouping. That is the true meaning of the AC method. So let us just take our time, find out what is A, what is B, and what is C. So A is the coefficient of the square of n, and this time it is 2. B is -3, and our C value is -20. Doing the AC method, we need to find out what is A times C, and that is going to be 2 times -20, and that will give us -40. So right there, and then we have C, AC is equal to -40, right? AC is equal to -40. So here is the thing. We need 2 factors or factor pairs of 40 that can produce a 3. I'm seeing a 5 and an 8 already. But let us say you don't know. What I would advise you to do is to list them. Like we can list the factor pairs of 40. We could take our time and list them here. For example, 1 times 40 gives us 40. 2 times 20 gives us 40. 3 times nothing gives us 40. 4 times 10, that gives us 40. 5 times 8, that gives us 40. So we try to find, and there it's actually a limited set of factor pairs that can produce 40. So then, now you can say then which one of these pair can actually give us a 3. There's no way by adding or subtracting we could get a 3 there. No way we can get a 3 here. Can't get a 3 here, but definitely we could get a 3 with a 5 and an 8. So a 5 and an 8 can give us a 3. If the 2 numbers that you're going to choose, all right, when you find them, and if your AC is a negative number, one will be positive and one will be negative. Let the bigger number take any sign that B has. So 8 will be negative and the 5 will be positive. So we want to make sure that when you multiply this, so in other words then, +5 times -8, you could see -40. And then if you add these, you will get your -3. So you're seeing your AC and you're seeing your B value coming out at the same time. So we're suggesting that those are the numbers. So let us drop those numbers in the middle, all right? Let's drop those numbers in the middle. So we're talking 2n squared, and I'm going to write plus 5n minus 8n minus 20, right? It doesn't matter which one of these you put first, you'll get the same response. So you don't have to worry about it too much. Anyone you want to put first, you go ahead and do it. So I'm going to bar off those and I'm going to bar off those. So I'm having my first pair and then I'm having my second pair. All right. So let's go back to that. What is the common factor for the 2n squared and the 5n? The common factor is n. So I'll take out the n, open a bracket, divide my common factor into 2n squared. I'm left with 2n. Divide the n into the 5n, and then we get 5. Remember now that I need to make sure that I get a 2n and a positive 5. Positive 2n, positive 5. So I'm going to have to use a -4 to work for this. So -4 into -8n will give a positive 2n. -4 into -20 will give me a positive 5. And the moment I realize that my brackets are twinning, so my brackets are twinning, then I know that I'm good. I'm going to just write back one of those brackets there, and then the other two things on the outside, and I'll point at them. We have an n and we have a -4. Those will go in the other bracket when you factorize, and we're done. All right, so let me see. All right, Chad, you have to check your thing, Chad. I see with a +4, it has to be a -4. The +4 would not have pulled it off. So you have to be careful when you're factorizing. You want to make sure that you're not just writing back things in the bracket. You want to make sure that the things actually work themselves out to produce what we're seeing there. So we're looking at 2n plus 5 into n minus 4. 2n plus 5 into n minus 4. And that should take us out as it relates to getting our answer right there. All right. So I'm looking at the chat here. Not seeing much of a response. It seems that the paper 2 is kind of holding us right a little bit, but it's fine. So let's see what's going on. Let us see what is going on. All right. So, okay, El Cisco, very good. All right. Let us now look back at this other question. All right. This is a very nice question here. So the question says, a candy store, right? It says a candy store. A candy store package lollipops and toffees in bags for sale. So we're seeing our lollipops there, we're seeing our toffee there and stuff like that, whichever one is, right? So one is X grams and the other one is Y grams, all right? So here's the question though. Here's the question. The question says 5 lollipops and 12 toffees they would have a mass of 61 grams, and then 10 lollipops and 13 toffees have a mass of 89 grams. All right. So then we're going to set them up somewhere up here so that we could get some working space. The question reads, it says, if the mass of one lollipop is X, but we're seeing that X grams, and the mass of a toffee is Y grams. So they're telling us we're going to be dealing with variables X and Y's for the lollipop and for the toffee respectively. So it says write 2 equations in X and Y to represent the above. This is a simultaneous thing, and that is why they gave us 2 cases that produce 2 different results. So in other words then, lollipop is X. So we're talking 5X plus 12Y, and that gave us 61 grams. So you're seeing that idea going up, and this is our first equation there. Second equation, we were told that 10x, because it's 10 lollipops plus 13 toffees, and this is why, and we got 89 grams. So we have our situation 2 there. So right there and about, we could have quickly collected 2 marks right here just to produce those simultaneous equations there. Now let's see what they want us to do though. What it is that they want us to do with them. The question says, calculate the mass of one lollipop, that's A, and B, one toffee. All right, so we want to solve for X and Y, basically. All right, so we could shift a little bit here and get some working space, I believe. All right, so we could work them anywhere up here. All right, let me pull down this just a little bit right there. All right, so let me rewrite these over the side here. So we have a 5x plus a 12y, and this is equal to 61. All right, 5x plus 12y is equal to 61. Then we have a 10x plus 13y, and this is equal to 89. All right, and this is equal to 89. Situation 1, situation 2. So I'm going to push my screen across to get more writing space as we go. All right, I could leave it there because we're just solving now. We could go back after that. Situation 1, situation 2. All right, what we could do is just to eliminate any one of these variables that we intend to, right? So it's up to us. So let us say I am deciding that I want to eliminate the x's. So here are the x's. I want to eliminate the x's. So if I want to eliminate the x's, then I'm going to be picking on the coefficient of the x's, and that's a 5 and that is a 10. So I'm going to use them to multiply throughout. So in other words, I'm going to create two more equations, right? I'm just going to create two more equations. All right. So I'm going to just say, guess what? I'm going to use the 5 down here because we have to flip them, and the 10, I'm going to use it up here. I'm not saying you have to do it this way, because the truth is I could have just done it another way, but just working at a standard procedure that people could follow all the time. So I take them, 5 and the 10, and I switch them. If you notice, the 5 is in equation 1. I'm going to use it to multiply by equation 2. The 10 is in equation 2. I'm going to use it to multiply by equation 1. So we have to look how we switch it. Why are we doing this? Because we want to get back certain numbers. So let's go. 10 times 5, that's 50, x. 10 times 120, that's 10 times 12, that's 120, y. All right, so 10 times 5x, 50x, 10 times the 12y, that's 120y, and 10 times 61, that's 610. Now let's go for the next, let's go for the next one. So we're saying now 5 times the 10x, that's gonna give me a 50x, and then 5 times the 13, I think this is gonna give me a 65y, and then 5 times the 89, 45 minus 5, 89 times 5, and that is going to be 445, I believe. All right, so there are my numbers. All right, very good. Now, as you could see here, what we want to do is just to eliminate this, eliminate these. We're going to eliminate them. All right, because when you get back those same numbers, you can either add or subtract, but you could see subtraction will work here. So we're going to have to subtract. So this is equation 3, this is equation 4. So I intend to subtract equation 4 from 3. So I'm going to be writing equation 3 first. Already, we would see that this is 50x minus 50x. That's gone basically. Then we have 120y. Subtract 65y, then we have 610 minus 445. So I'm subtracting equation 4 from equation 3, as you could see there. Now, we're simplifying as we're going along, subtracting. We realize that these would have gone, all right? So the 50s would have gone. I'm now left with, let's subtract 120, I think that is about 55. 120 minus 65, I'm left with 55y. And then 610 minus 445, I'm left with 165, right? Now, to find y, we'll divide both sides. Yes, divide both sides by 55. Divide both sides by 55. Y is equal to 3. So y is equal to 3. Y is toffee. So it simply means that we're talking about toffee. One toffee has 3 grams. We're talking about 3 grams for the toffee. That's what we're talking in terms of the mass. The mass of the toffee is 3 grams. All right, so the mass of the toffee is 3 grams. So we found this one right here, 3 grams, right? Now, because we know that the mass of the toffee is 3 grams, what we can do is just to substitute that in any one of the equation that we have, any one. So we could just pick on one because we know, because we are aware of this, all right? So we are aware of that. We can then say, guess what? Using back 5x plus 12, and I would say to you, you could use any one of the 4. Any one of the 4 could work, all right? Any one of the 4 will work, all right? Very good. So it's going to be 5x plus 12 times 3, and this is going to give us 61. So we're working ourselves through 5x plus 36, and this is equal to 61. So then we're going to subtract 36 from both sides. Hold on, let me write this 6 better. 5x is equal to 61 minus 36, and that's 25. So I'm getting 25 there. So if I divide both sides by 5, I realize that x will be 5, meaning 5 grams. So that means the lollipop, yeah, lollipop has a mass of 5 grams. So we could respond to that right there. So the lollipop has a mass of 5 grams. We could put that right here, 5 grams for the lollipop. And there it is. They would have given you 4 marks to write that question out. All right. So as you could see, it's a simultaneous equation, but this is the way that they brought it to us this time. It was given in a real life situation, and we had to create the system and then solve it whichever way we feel comfortable. I use the elimination method there and then substitute after. Right. All right, let's continue. Let's go. All right. So now for this other one here. All right, this other one, what are we having here? All right, so we are having a vector. All right, one of those nice vector questions, I believe. Yeah, having a vector. So, all right, so we have a vector question this time coming up. Vector coming up, you could look at it. All right, Anderson, I see your answers coming out very good. El Cisco coming out good with your answers there. All right. All right, so what I'm going to do is just pause for a little minute and give you a chance to just put together your response. All right, so I want you to put together your response for this, right, in the form, the vector OP and OR. Or you could just write OP, all right? Somebody could just quickly write OP if they wanna. Let me see if anybody could come up with OP. I'm giving you a minute to put it together, and then I'm going to definitely start looking at it after that, all right? Giving you a minute to put it together. OP. All right. All right. All right. So let's look at it. Let's look at this now. So with this vector question, all right, it says OP and OR are position vectors. All right. And they did say to us with respect to the origin O. So everything is linked to O. That means that's why you see OP and you see OR. And then now they told us that the point P is 2, 7. And they gave us now the vector PR, which is 4, -3. We want to, looking good, oh well. We want to understand that whenever we get a coordinate in a position vector system, we actually have the position vector from the origin to where the point is. So OP is going to be linked to the point P, so it's going to be 2, 7, like that. So that is OP. OR, we're going to have to put some working together to get OR, all right, because we were given PR, all right, we're given PR and we have OP. So we could, to find OR, if you think about this carefully, OR is to move from O to P and then move from P to R. So we're saying that we want to look at the movements of the vector. And this is how vector move all the time. Very simple. Move from one place to a common ground, and then we're going to leave that common ground to our final destination. We're ending at R, OR. So OR is OP. So OP is okay because this is the same OP, the same direction. So we don't have to change anything. Plus PR. And we got PR in that same direction again from P to R, and we're using it as P to R. So we have 4, -3 coming here. So let's finally put this together. OR is 6, 4. OR is 4, 6, 4. All right, put it together. 2 plus 4, that is 6, and 7 minus 3, that is 4. So OR, so let me just write OR here, because I might not have the space to put it there. All right, so OR is 6, 4. All right, I could probably drop it there. 6, 4. There it is. So OR is 6, 4. All right. All right, good. All right, good. All right, so the next question though says that a point S has the coordinate 14, -2. The point S has the coordinate 14, -2. All right, so it simply means then indirectly, I'm just gonna claim this right now. The point S has the coordinate in it and it's in the system. So that means we have the position vector from O to S, which is 14, -2. So whether or not they ask about it, we want to know that we have this idea ready to go in the event that we need to do anything with our OS, because the moment you give me a point in a position vector system, you have indirectly given me the position vector from O to that point, only that you need to write it in a vector format. Hence, I would have written the coordinate here in the vector format right there. Same numbers, right? All right, so let us now look at what they want. They want us to find RS. All right, so if you want to find RS, RS would mean that you're going to be traveling from R to O and then O to S, because there is a link. So let me try to put this, hold on, let me put this at the side a little bit right there, and then pull this down here, and then I'm going to do the working up top here. So they want us to find RS. So if we're going to find RS and you're in a position vector system, remember all the vectors are linked through the origin. So we're going to move from R to O in that direction, and then we're going to be leaving from O to S. And you can see it's a simple walk. And this is what you're going to do every single time. And guess what? CXC love position vector. Position vector every single time. So many times it's going to be position vector. So here is the thing now. Here's the thing. So now we're looking at it that we're saying that what is RO? We just found OR. OR is 6, 4. That means changing the direction of that, we're going to be having -6, -4. Remember, whenever you change your direction, the signs on the components would have changed. All right, we're going to be adding that to OS, and OS is in the same format of O to S. So we're looking at this. So finally, no mistake now, we're talking about -6 plus 14, and that is an 8 at the top. And then -4 with a -2, and we end up with a -6. All right. So we have +8 and a -6. All right, there you go. +8, -6, +8, -6. All right, and I'm actually seeing something already. I'm seeing a link to PR. Now, let me write this right here. I'm going to put it right here beside it. I have this space. I could just put it. So RS was found to be 8, -6. Now, look at this 5-mark question. For those of you who have been in the class and you would have seen us going through, you would have learned that, hey, the collinear idea is to look at the 3 points, create 2 vectors from it. So we could get 2 vectors out of that. But guess what? You see, whenever you are working this problem, the first thing you do is to look to see if whatever they ask you to do already, you are getting vectors from it. So I'm getting RS already. I'm getting RS out of it to be 8, -6. They asked me to work out that. So RS, I'm seeing R and S, and then I'm seeing PR. And the question start off with PR. Check it out. The question start off with PR, which is 4, -3. So definitely, I don't have to work out any other vector, because in proving collinear, I only need to have 2 vectors. And having those 2 vectors, I am able just to put it together and like that. So what is the concept of collinear? Right? Let me put the concept of collinear at the side. Whenever we discuss collinear, I could just put it right here. Whenever we discuss collinear, the concept of collinear is to prove that 2 vectors are parallel. So we want to prove what is called parallelism. Right? So we want to prove that 2 vectors are parallel, and while being parallel, they share a common point. Yeah. So while being parallel, you want to make sure that they share a common point. So all we have to do is to observe. So collinear, parallelism, prove that they are parallel, and then look at those two vectors while being parallel. If they share a common point, it's done. So here is the thing. Now you're seeing here that when you observe vector PR and vector RS, definitely you could say something. Yeah, you could see that 2PR, yes, 2 times the vector PR would give you the vector RS. 2 times it. So in other words, then I am able to factor out 2 out of RS and end up with PR. So you could see that. You could see that right now. You could see that right there. So if I take a half of it, like I could say, okay, I could rewrite, I'm just saying this, extra word. I could rewrite RS as in 2 times 4 negative 3. You are seeing I could do this. And if I distribute the 2 inside, I'll get my 8 negative 6. So you're seeing that I could pull it out. All right. So this is telling us that PR and RS are parallel. All right. So then they're parallel and they share a common point, R. So we're good to go. We're done. So 2PR give us RS. All right. So then we just found out that, guess what? 2PR produces RS. So this means that they are parallel. So then the fact that these two vectors are parallel, all right, and that they share the common point R. So I could say to you that, guess what? PR, yeah, and RS also share a common point. And I'll name the point. All right. So then this means that they are collinear. It means that this means that therefore P, R, and S are collinear. That's all it means. So the idea is that whenever collinear comes about, what you want to ask yourself is this: am I able to prove that 2 vectors using those 3 points, 2 vectors are parallel? And parallelism of vector is just to be able to factor out a number. Doesn't matter what it is, whether it's a rational, a fraction, or it is a whole number, factor it out. And then if you can factor out one thing and then see the other vector showing up, that means they're parallel to each other. If you can multiply one vector by a number and get the other vector, it means that they're parallel as well. So as long as you're able to do that, just show it. And then that will be enough information to say that they're parallel. And then just show them that, listen, while being parallel, they do share a common point. That means they must be on the same line. And then that is our collinear. We're done right there with the collinear, right there. So the collinear right there, that is how you prove collinear, right? And it does not get any harder than that. It's just that from time to time, we don't know what is going to be that thing to factor out or that thing to be multiplied by the other thing. So you have to observe the vectors that you have, and then you will see, by looking, you will see the number that is needed. All right, here's another sheet that coming up. So I just have various sheets that are scattered all over. All right, so we're moving from a number 10 to a number 2, a number 5, a number 4. All right, so we're trying to do as many as possible. And remember to name the common point. Name the point. Don't just say share the common point. Tell the common point that they share, and you're good to go. We don't want to leave any information off. All right. So we're going on to factorize. Again, another question pops up that says factorize. Let's look at this one. We're looking at 2x to the third. 2x to the third, let me step to number 3. And then we have a y there, and then we have plus 6x squared, y squared. So these are what we have. Factorizing, what is good for the number? you'll definitely see that for the number, 2 would work for the coefficients. All right, 2 would work for the coefficients. And what would work? X and then Y. Remember that when you pick a letter, you have to use the smallest power of the letter. So X to the second power is what you want to use for the X's. And then for the Y's, Y will work. Remember, again, whenever a letter is a common factor, use the lowest power in the situation. All right, so we open a bracket. And then when you divide now, we're going to have an X coming out of that. Only an X coming out of that case there. All right. So if we divide 2x squared y into 6, the 2 will give us a positive 3. The x square will cancel fully, and the y will cancel, leaving a y there. So we're looking at this to be 2x squared y, open bracket, x plus 3y. I was looking for that. I'm not sure if anybody did it. Yes, Chad, I just saw your comment. You could have said half, all right? It's okay. You could have said it, Chad. Good to go. All right. Now, let's look at this second one. So this one, again, is the difference of 2 squares, right? You could see that it's the difference of 2 squares we're looking at. The difference of 2 squares going on right now. So in the difference of 2 squares, here's what is going on. We're looking at, let me write it at the side. We have 9x squared minus 4. You're seeing that the 9x squared is a square term and 4 is a square number. Where is it coming from? The root of this is coming from 3x that was squared minus 2 that was squared. So when we talk about difference of 2 square, talking about 2 square things subtracting from each other. So therefore, the beauty about this 1 mark question, you know, it is the first one was for 2, this is for 1, because they're not expecting you to do a lot of work. All right, so you have a 3x and a 2, a 3x and a 2. All you have to do is to put a plus in one, and you put a minus in the other one, and it's done. If you feel like you want to put a minus first, then a plus after, that is also good and can be worked with. 3x minus 2, 3x plus 2. Excellent work again, and very good. Otavia, I wanted to throw those comments out on my live. I'm not seeing you out on the live, Otavia. All right. So 4x plus. So we have 4x. Very good, Samantha Bradford. Excellent work, Anderson. All right. All right. So let's continue. We have 4x squared plus 8xy minus xy minus 2y squared. What we're going to do though, normally when you get these problems, what you want to do is just to quickly look if you could find common factors for them as is. And if that's not happening, then that's when you start to move things around. So I'm seeing 4 and an x that could work for situation 1, and I'm seeing y, a negative y, that could work right there. So we're good to go with this as is. Let me just pull a line here and then see if I could work this here. And then I'll do the B1 somewhere else. All right, so 4x squared plus 8xy minus xy minus 2y squared. All right, so for these two, 4x would work. So we're taking out 4x. 4x into 4, x squared, that's going to be an x. 4x into 8xy, that's going to give us a 2 and a y coming down. Let me see if anybody would have any answer yet. I'm seeing some answers. And then minus y would have given us minus y into minus xy, give us positive y, positive x, I should say, my bad, positive x. And then minus y into the minus 2y squared, then we're going to get positive 2y coming out. You definitely see that my brackets are twinning. I love when they twin up. Whenever they twin like that, we know that we're on the right path. Then we're going to write back with just one of those identical twins, just one. And the other 2 things will come in the other bracket, basically. So we factorize again, we'll get 2 marks to do that factorization. So x plus 2y into 4x minus y, right? That's what I'm looking for. Come Tavia, jump on the YouTube, man. I'm looking for you there. All right, almost. Samantha, remember you have to finalize it. Samantha, you have to finalize it and then double check your response. Samantha, double check the response. All right, there's all right. So this equation here, let me push this to the side, push it up, give myself a little bit of space. I'm going to write the equation over here. So let me write the equation here. So we have 2x minus 3 all over 3. And then it's going to be added to 5 minus x over 2. And this is equal to 3. There it is. So 2x minus 3 all over 3 plus 5 minus x all over 2 is equal to 3. So here is the deal. We're solving, just making sure that I wrote off the exact thing there. All right, so we're solving for x. So I'm gonna just give myself a little space right there. What we wanna do though, whenever you're solving these sort of problems, is that you wanna get rid of the fraction very early. So you wanna find something that the denominators can go into without a remainder. And we're talking about the 3, we're talking about the 2. We want to get those out very, very early, which means that I need to find something that I could multiply throughout so that they could cancel into. So what's a good thing to work for the 3 and the 2? A 6. So I'll say, guess what? 6, I'm going to use 6 to multiply by the 2x minus the 3 over 3. And then I'm going to be having my 6 again. That will be used to multiply by my 5 minus the x over 2. And this is going to equal to 6 times the 3. We want to see what's going on, because we're using the 6 not just where the fraction is, we're using it throughout for balancing. The left side, right side, fully. Why did we do it though? We did it because we intend to do some canceling. So yes, we could cancel 3 into itself 1 time, 3 into the 6, 2, 2 into itself 1 time, 2 into the 6, 3. So you could see the canceling. Then we're going to rewrite the thing and then see what we have. I'll take my time. I'll have 2 here. Then I have 2x minus 3. Then I have a positive 3, open bracket, 5 minus x. Then we have, I could just write 18 now. 6 3s give us 18. Then now we want to distribute. All right, so we're going to distribute, get rid of the bracket. So 2 times 2x, and that's going to give us 4x. 2 times negative 3, that's negative 6. 3 times 5, that's positive 15. 3 times negative x, that's negative 3x. And then we have 18 out there. So then we want to collect our like term. So no rush anyway, 4x minus the 3x. And the negative 6, and the 15 will give you 9, right? Negative 6 and 15. Let's make sure it's like a positive 9. And then this is equal to 18. So we're seeing what's going on. We're moving. We're cleaning up. So if I rewrite this, 4x minus 3x is actually x. All right. So that is x. And then I want to subtract 9 from both sides. So you could see the 9 being subtracted there. X is equal to 9. Anybody got the 9 there? Anybody there got the 9? Anybody got the 9? Waiting to see if anybody posts the 9 there. So we're looking at 9. That should be the answer. All right, just looking. All right, Chad. All right, Chad. I see you coming in with your 9. Good to go. Good to go. X is equal to 9. Excellent working. All right. Let us shift a little to the other side. We're going to be handling that simultaneous equation there. So there's a simultaneous right there. Let's blow it up. It's right there. We could shift it right there to the corner. All right, so we're going to be solving that simultaneous equation. We're going to put it in that spot that we have there. So what is this simultaneous? It says here, it says 3x minus 2y is equal to 10. And then we have 2x plus 5y, and this is equal to 13. Right? So what we want to do, this is situation 1, situation 2. All right, situation 1, situation 2. Let me try this one. All right, good. So situation 1 and situation 2. Let us say I intend to eliminate this. I'm changing up this time, and I am eliminating the y this time, right? If I'm going to eliminate the y's, all I have to do is just to focus on the coefficients, right? You don't have to worry about the positive and the negatives really right now. So you could just use the 2 down here. You could just use the 5 down there. If you use your negative, it's fine. You can, but you don't need to. All right. So we're going to create some more equations. 5 times 3, that is going to give us 15x. 5 times negative 2, negative 10y. 15x minus 10y. 5 times 10 is 50. 2 times the 2 is 4x, and 2 times the 5, that's going to give us 10y, and that is equal to 26, 2 times that. So making sure that there's no error in our multiplication, that is situation 3, that is situation 4. All right. So just making sure that's what we have. So 15x minus 10y equal to 50, and then 4x plus 10y is equal to 26. So we're making sure that we don't have any errors there. The aim of this though is to ensure that these numbers would have come back, and they did come back. So at this point in time, there are different signs. So if I have a negative and a positive of anything and I fuse them together by adding, they will be 0 out. So it's going to 0 pair out. So adding. So what we want to do is to state that we want to add equation. All right, I don't like how that look. Let me take that off. What we want to do is that we want to add equation 3 and 4. All right. So in doing so, we'll have 15x plus 4x. And then this is gone to 0, and then we'll end up with 76. This looks like 19 to me. 19, 4 looks like 4. Let's go. 19x is equal to 76. So divide both sides by 19. I believe I'll get 4. So x is equal to 4. So there it is. We have found one of the answer. So x is equal to 4. So having found x is equal to 4, what I could do with that though is that I'm going to use that to substitute in any one of my equations to find a value for y. I'm looking for a spot. So I'm going to put it, I'm going to work backwards sort of. So the fact that I know that x is 4. So I could say, remember now that x is equal to 4. So because x is equal to 4, I could say using 3x minus 2y is equal to 10. I could say, guess what? I could use that, and I'm going to substitute the value of x right here, right? So then it's going to be 3 times x, but x is now 4, equal to 2y, which is equal to 10. And at this moment, we will realize that now the x is gone. So we have 12 minus 2y equal to 10. Subtract 12 from both sides so that the 2y could stay alone. So negative 2y is equal to negative 2. Finally, I'm going to divide both sides by negative 2, not 2, so that the negative 2 cancels itself. Negative 2 cancels itself, goes into it one time, 1. So y is equal to 1. I could now conclude that y is equal to 1 and x is equal to 4. So there goes our solution for this. There it is. Right, there it is. Y is equal to 1 and x is equal to 4. X is equal to 4. Yeah. All right. Good. All right. So let us all right, let us look now. So that was there for a while. Let's look at this one. This one is a measurement question. Yeah. All right, as I said to you, we're all over the place, picking and choosing questions from various strands. All right, so we have everything there going about. So let's jump on this one. This one is a measurement question. So what it says here that the diagram below, not drawn to scale. So not drawn to scale, shows the cross section of a prism in the shape of the sector of a circle with center O and the radius 3.5. The angle at the center is 270 degrees. So there it is. We're given all the information that we really need. We were told that this is 270 degrees right here, 270 degrees right there. So we have everything that we need. We're going to be using pi as 22/7. So let's see the first question. Remember though what this says. This says that this is the cross section. So that means there is a solid. Let me see if I could get a solid. Let me see if I could kind of draw this. Just a rough thing. There is a solid that looks like this. It really looks like that. That's what it looks like. That's what it looks like. That's what it looks like. That's the idea of it. So they're saying that there's a solid that's shaped like this, all right? And this part of it is the cross section. So it exists throughout and it exists all the way down there. So it is down there looking like that, just the same. So that's what they're saying. That's one. That's an idea. That's not a good drawing, but at least it can give an idea of the solid thing that we're dealing with. So it says, what we want to do though is to calculate the area of ABC. So ABC is the dotted, it's a shaded part, right? Which is actually the sector, all right? Remember, you get this formula from CXC though to find the sector of a circle. So I probably just put it by the side right here. So the area of ABC, all right, is equal to, we could use theta over 360 times pi r squared. So we're referring to 270 degrees out of the 360 times pi, we got that to be 22/7 times r, we're told that it's 3.5 squared. So this will just give us that shaded area right now, which is the cross section. So all we have to do is to take our time and put this out on our calculator. So I'm going to work the values at the top and then, you know, just take 2 steps and write this out. So I'm going to get the top value. So 270 times 22 times 3.5 times 3.5. All right. So that top number, and I need verification, that top number is 72765. All right. Let me just double check it. So we're talking 270 times 22 times. All right, good. And then now we're going to be divided by 2,520 at the bottom. So I'm going to just carry it out now. So now I'm going to do my final answer, 72765, and then I'm going to divide this by 2,520, and then this becomes my area, 28.875, but I'm going to use 28.9. All right, so my area is equal to 28.9, because I'm using 3 significant figures. They did not give me any specific instruction, so I'm using 3 sig fig to do that. And that is what we do all the time. When we're not told exactly what to do, then we handle it that way, all right? When you're not told what to do, you handle it that way. All right, so there it is. We have found that. Yes, area, ward, area. Oh, my bad. I didn't even realize that this says arc length. I was finding area of, I was actually finding area of this, right? All right, so that's my bad there. area right there. So let's go back up there. That's so I found the area of O. I found the area of the shaded region, right? Because I was looking at the last question by error. So I was looking at finding the area of the sector, right? So that's what I found. So that's what we worked out first. All right, no problem. Just that we work out that one. So we're gonna find the arc length after and the other one. So I was working out the area. As you saw, I write area of that here, all right? So that's me jumping ahead. All right, good. Very good word, looking out. All right, so let's go back to the first one here, this one up here. We're gonna be finding the arc length. I think we could put it, no, probably we need space. We're gonna need some space. So we're gonna shift it a little to the side. So we're gonna find the arc length. Let me just mark it. We're gonna find this distance here right now. That's what we should have found earlier on, but I found the area. All right, no problem though, because it's there on the paper to find. I look at the wrong one, but we're gonna find that blue mark right there. That's what we're gonna be finding now, which is the arc length, all right? So finding the arc length is a similar setup, very similar setup. So arc length is equal to theta over 360. And guess what? CXC give you this times 2 pi r. 2 pi r is coming from circumference. So arc length is a part of the circumference. So hence, this is just a part of the circumference of the circle. And that's where we're heading now. So basically, let's go for that arc length. So we're gonna have 270 over the 360. The numbers are the same, except this is circumference now. 2 times pi times r, and r is the same, 3.5. And there we go. Let me write this better. All right. So let us just take our time and do. I'm going to work out the number at the top over the number at the bottom. So I know the number at the bottom is that. So at the top, 270 times 2 times 22 times 3.5. So we're looking at 41580. All right, very good. 41580. So double check it again. Just double check 270 times 2 times 22 times 3.5. So 41,580. And we want to divide that now by 2,520. And I think you should get something like 16.5 centimeters. I need somebody to, yes, Chad, very good, 16.5 centimeters. So that's what ought to be here, 16.5 centimeters. Very good, right there, 16.5 centimeters. All right, so that's that. So that's the arc length, meaning walking all the way around, you will get 16.5 centimeters. Walking all the way around that blue shade that I placed there, you would have gotten that. So the question though is saying that the perimeter now. So the perimeter is that we're going to be adding up all the distances along the boundary. So 3.5 is going to be here because it's the radius and it is the same. So you're going to be moving from C to O to A and walk along the nice blue line coming back. So basically we're putting together, I think I could just put it in the middle right there. We're going to put together 3.5 plus 3.5 plus 16.5. And that will give us our final take on the thing. So let us go 3.5 plus 3.5. Double check with me as we go. Plus 16.5, 7. So 23.5 sounds good to be that perimeter. 23.5, I could put it at the back. 23.5 centimeters right there. All right, and the fact that we work out the third question already, fine. So we're finished with that, 2 marks each for that part. All right, excellent work, Lopez. Excellent work, Chad. Excellent work, Milan. Seeing some Samantha doing some, getting some answers up there as well. Very good. All right. Very good, guys. Very good, very good, very good, very good. All right, let's go. Hold on. My bad. All right. Right there. Ward, it was there, man. You're not looking. It was on the side. Ward, I think you'll know, but it was there. Ward. All right, let's go. Let's continue on. Let's continue with the questioning. So now, so this one now, it says the prism is 20 centimeters long. So that's why I kind of put this out early, that so-called ugly diagram. Here, they're saying that this distance here, that distance is 20. So it is 20 centimeters long from top to bottom. Remember that we found the area of it to be 28.9. So we can easily find the volume because the volume is going to be area of cross-section times the length. So now that I'm getting the length and I've found the area already, we're good. Good. All right, so the diagram there now is coming in handy. So the volume is going to equal to the cross-section area, which is the 28.9 times how long the thing is, which is times 20, just like that, right? So let me push this up a little bit. 28.9 times 20, and we get, hold on, 28.9 times 20. And I'm thinking I'm getting about 578. You can verify with me about 578, and then this is cube talking, cube. 578 cm cube in terms of the volume of that cube. Because remember, you know, the moment you have the cross section, so I could just put it on the side that the volume is your cross section, yeah? I'll just put cross section area and you multiply that times your length, or depending on the orientation, length or height, all right? So in this case, we really had height. All right, so area of the cross section times the height, same vibes, 28.9 times 20, and we get 578 cm cube. All right, so that is the volume of it. Now, to finally write out the question, it says the mass of the prism to the nearest, they want the mass of the prism to the nearest kilometer. All right, the mass of the prism to the nearest kilometer. And they're saying that, hello, given that one centimeter cube of tin has a mass of 7.3 kilogram. I think I said kilometer just now. So let me reread. The mass of the prism to the nearest kilogram, all right, which is kg. And then they're saying that 1 cm cube of the tin has a mass of 7.3. Think about it, you know. One cm cube has a mass of 7.3. But remember now, so I'll say to you, the total mass in kg is going to equal to 7.3 grams, kilograms, you say, multiplied by the 578. Because remember, they are saying for every 1 cm cube, then it's going to produce 7.3 gram. So by the time I reach 578 cm cube, I just need to multiply 578 by 7.3, and then I'm going to get this answer, 4219.4 kilogram. But in a response to the question to the nearest kilogram, the answer is 4219 kg. Because when they say to the nearest kilogram, they're actually saying to the nearest whole number. All right, that's what it really means. So it's the nearest whole number you're going for. So we would have rounded down because 4,219.4 will be rounded down. All right, unless the calculations are off, but the calculations are spot on. 4,219.4, but when it's rounded down, it's going to be 4,219. For this question, if you don't give the answer as this, you will lose 1 mark out of the 2 because you have to respond to the fact that they want it to the nearest kilogram. So very importantly, that was needed. All right. All right. We have been touching a number of questions. Yeah. We touched a number of questions, as you could see. All right. Number of questions. So let us continue on the journey. Here it is. Trigonometry comes up now. We have trigonometry comes up. All right. So let's go. Let's go for this one. So this one comes under measurement, geometry, and trigonometry. So there it is. I think it's going to be a long question. Yes, it is. All right. So let us let's get on board. It says the diagram below, not drawn to scale, shows a quadrilateral QRST in which QS is equal to 7 centimeters. So QS is equal to 7 centimeters. ST is equal to 10. QT is equal to 8. Angle SRQ is equal to 60 degrees, and angle RQS is equal to 48. Every single thing that we're looking for is on the diagram already. We don't have anything to label. All right. Exactly, Chad. Chad said the sine rule already. RS. Where's R? Yes, Chad. RS is the sine rule. I agree, sir. Definitely. All right. So they want us to find RS. So RS is opposite to 48 degrees, and they gave us 60 degrees and said 7 is opposite to it. So because of that crisscross thing going on, meaning I have an angle on its opposite side, then they gave me another angle and said, find the opposite side. The moment we're seeing stuff like those, yes, it will be the sine rule. So let us just put it to the left here. The sine rule says that A over sine A over the sine of A is equal to B over the sine of B. So in this regard, I'm going to say 7 over the sine of 60 degrees is equal to RS over the sine of 48. So that's the setup. That's the setup. Look at the arrows, follow the arrows, the sine rule, right? So now, again, we can do our quick cross multiplication. All right, RS times 60 is equal to sine 48 times 7. I mean, if you want to do that, that's fine. If you want to just multiply both sides by the sine 48, but I'm trying to get people to just develop a systematic way of working out. Chadwick. All right, so let us go for the answer now. So we are saying that 7 sine 48 is equal to RS sine 60. And you could see that we want to find RS, so we'll divide both sides by the sine of 60. And remember, it's going to give us the answer. It's the length we're finding. So this working out will give us the answer right now. So we're saying 7 times the sine of 48. Make sure your calculator is in degree, please. And then we want to divide that by the sine of 60. And then I'm getting 6.00. So basically, it is 6. I'll just take 6, but I'm getting 6.00. So 6 is good. See, so I'm seeing 6. Very good, Chad. All right. All right. Sine rule, Otavia. Good, good, Otavia. All right. All right. So the answer is definitely 6. All right. Very good. So label the triangle so that the next question, would be a little bit more easier. All right. It says the measure of angle QTS. QTS. I want to mark the angle QTS right there, and then I'm going to shade the angle with a nice blue right there. All right, shade the angle with a nice little blue right there. So that's what we have dealing with right there. So then we want to find that angle. If you look carefully though, we don't have any other angles, but we can use the cosine rule, because the cosine rule is that even though we don't know this, but we have the side across from it. And then we have the angles, we have the sides that surround that angle. So it still does not matter as long as there's an angle between two known sides. And sometimes you are asked to find the side across from the angle, and other times you're asked to find the angle. So in this case, we're going to set it up and find the angle using the cosine rule just the same. So there it is. We're going to say 7 square, because the formula always start by saying the side across from the angle square. We want to make sure we understand that. So 7 square is equal to 8 square plus 10 square minus 2 times 8 times, let me write my 10, times 10 times the cost of the angle that we intend to find. So now from there, we're suggesting that 7 sevens is 49, 8 8 is 64, 10 tens is 100, and then all of this is going to give us about 160 cubed. So I'm going to say 160 cos of this angle. All right. So make sure that the numbers are really good there. All right, good. So let's put it together because we're solving. So basically then I have 100, I have 49 minus 164 because this is 164 here. And so I'll subtract 164 from both sides basically. All right. And then I'll have minus 160 with the cos of the angle. All right. Then now we're almost there. 49 minus 160 is going to give me negative 115, which is equal to negative 160, the cos of the angle. And I'm at a good place because now I will divide both sides by 160, negative 160, negative 160. So dividing both sides by negative 160, and I'm getting 0.7188 to 4 dp. That's okay. All right. So then in order to find the angle, now I have to go cos inverse. So I'm going to go cos inverse of 0.7188. And that is going to take me to the answer. So cos inverse of 0.7188, and I'm looking at 44 degrees. All right, because it's 44.0, so I'll get 44.0 degrees, or you could just say 44 degrees. That's the answer right up there. I got 44 degrees up there. All right, very good, very good, very good working out. Looking at what is going on here. This is your exam. This is your exam. Don't think it's going to be harder than this. It's not going to be harder than this. This is the idea. This is the idea for the exam. All right. So those are 6 marks that you would have easily added to the other marks that you would have already been getting. All right. So the question says, the diagram below not drawn to scale. All right. So this one shows a circle. Diagram below not drawn to scale shows a circle, center O. The line UVW is a tangent. So I could just point out some stuff as we go, and then we could take it off as we go again. So this here is a tangent to the circle. That's what they're saying. You can see that. All right, good. So that's the tangent to the circle right there. And then we have ZOXW is a straight line. So they're referring to ZOXW. They're telling you that this is a straight line all the way going there. That's a straight line. We see that. All right. And then they're giving us an angle, UOX. So they said UOX in that corner right there, that is 70 degrees. And we say, all right, we're picking up that. Right here is our 70, and we're picking up that. No problem. Calculate showing working where necessary the measure of angle. And no, so they don't want any reason for these. So I'm not going to be giving any reason. All they ask for is to show working, right? So we're going to be showing working for our circles. All right, for those of you now who are looking here, basically you should be able to at least put out some answers now for the circle theorem. You would have actually gone through this already, so now is the time to show how much you understand. Put out the responses. Go ahead and put out some answer for your circle. See if you could come up with any answer before I actually start to navigate the thing. All right. Before I start to navigate, I want you to just jump on board and put out your answers right there. All right. So the first one that I'm going to be looking at is this says calculate showing working where necessary the measure of angle OUZ. OUZ. Let's mark that angle. Normally you have to mark that angle first, right? OUZ. I'm going to mark it OUZ. Okay, right here. Right here they want that angle right there. OUZ. If I should blow this up so you could have a better visual. OUZ right there. Right there. OUZ right there. All right. So by looking at that, we could do this. We could do this. If you notice, we were told that this is a straight line. So let me just mark by this. This is a straight line. And if it is a straight line, then it simply means then I could ride with the 70 to come across inside this here. I could ride on that. So this is going to be 110, and it would have been the fact that I know that that's 180 minus 70, a straight angle to get 110 coming on the inside at O there. And so that is now going to just allow us just to find everything else because right now this is an isosceles triangle. So if this is an isosceles triangle, as in ZOU or UOZ, or OUZ, any one of those you want to call, is the same isosceles triangle. The base angles here will be the same. So I'm going to say again, so taking 110 from that, we have 70, and then we want to share that 70 degrees equally for the two. So we're talking about sharing it, giving this one 35 and giving this one 35 because that's what it is. They would have gotten that 35 apiece as we go forth. Getting that 35 apiece. All right. So that means then that in a similar term, this angle is 35 degrees right there. Yes, Otavia. Chad, be careful. It's not 60. All right, 70 divided by 2 give us that 35 degrees. All right, very good, Otavia. All right, so we're looking at UVY. So it's going to be this here. We mark the angle, we look, stop, look, and listen. UVY. All right. So of course we could find that angle there right now. All right. U to V to Y. When you look though, there are a lot of things that are coming out here. This is a straight line from Y to U and it came to the center. It is telling us that this is 90 degrees because a radius meets a tangent at 90. You understand? Radius meets the tangent at 90 degrees. Also, this is 35 degrees right here. How did I know it's 35? Angle in the same segment. Angle in the same segment are equal. So I'm just saying, I'm just filling out things. Of course, I can find this now. Just observe that. So I could use the total angle in a triangle because I could say, guess what? The total angle should be 180 degrees. So if I say that 180 minus the sum of the others, what others? I'm talking the 90 degree here for this. And we have Y, and then we have V is what I'm trying to find. So then we're going to be adding that 90 plus that 35, yeah? So if we put all of that together, what are we looking at? 180 minus 125, and then we'll see our 55 coming out. 180 minus 90, yeah? Plus the 35 there, yeah? And then we're getting 55 degrees for the answer. 55 degrees right here. right? So we have our 55 degrees right there. Very good, Chad, very good, Octavia. Our 55 degrees right there. And then now, what they want us to find now is U, W, O. So from U to W to O. So now they're asking us to find this right here. Let me mark this angle. They're asking us to find that. If we think carefully though, of the triangle in question, we're talking about, let me use another color. Then we could just mark yellow, all right? Look at this triangle right here, this right here, this triangle right here. So you want to look at that triangle that I just point out from U to, so the angle says UWO, there's a triangle UWO. We have 70 and we have 90 already. So definitely we could easily find the third. It is, I'm waiting for somebody to post it, but this third angle is going to be 180 degrees, subtract the sum of what we know inside that triangle there. Yeah. This is 70. All right. So let's go again. So it's 180 minus 160, and your answer is 20 degrees right there. So you see your 20 degrees coming out right there. All right. All right. Very good, Chopper. All right. All right. All right. So we're getting out that. I would have gotten those marks for those working out. You show your working, collect your marks, and then you go and everything is fine. Everything is good. Now they want us to take it a step further. They just want us to look at some ideas because they're saying, says name the triangles in the diagram which is congruent to triangle. Congruent mean the same size, same everything, same angles, same everything. Everything is the same. I could label this for you and say, guess what? This is 35 too, you know, and this is 110 because looking at what's going on, right? So then Z, we want to find two triangles, one that is the same as ZOU. So ZOU is the same as YOX. Look at them, YOX. So we could say, hey, this one is YOX. So triangle YOX is twin. It is twinning for triangle ZOU. All right, so that's one. So they want us to find another triangle that is congruent. And we say congruent to talk identical twins, same size, same angles. YXU. Where's Y? YX. Where is U? YXU. Okay, YXU. All right. So you could see YXU is the same thing because there's a 90 degree here for YXU. So YXU is the same as ZXU, twin, identical twin, because there's a 90 degree here as well, in a different 90 from the one you're looking at, not this 90 here. I'm referring to there's a 90 degree here because this is a semicircle, an angle in a semicircle is 90. So we're saying to you that guess what? ZXU is congruent to YXU. All right, and so there it is. We would have picked up a number of marks there, 15 good marks. ZUX, yeah, if it says ZUX is the same thing. ZUX, same thing. All right, very good working out, guys. All right, let me say, all right, this is where we come to the end of our session. This is the end of our session here. But guess what? I won't be doing any live on Wednesday. So we're gonna gear up ourselves for the next live, which is gonna be Sunday. All right. So what I want you to do is to get as many persons to come because we're dealing with it, as you could see on YouTube. So it doesn't matter how many persons want to join. We're there at YouTube live. So prepare yourself, get ready, and get as many friends from schools, wherever you are, because we're going live again Sunday. All right. So I'll send out the posters and then you could start promoting it and pushing it around, you know, as we go forward, because coming Sunday, by the next Sunday, the week after that will be the exam. All right. So I'll advise you guys as we go on. If there is no class, then I'll let you know by tomorrow if I have to switch things to Wednesday. So keep your fingers crossed, because it might be this Wednesday as well as it might be Sunday. All right. All right, guys. All right, thank you for coming out, and I'll see you again. So hopefully it might be Wednesday. All right. So let's think Wednesday, Sunday. So by tomorrow you will know, but keep your fingers crossed for Wednesday. All right. Enjoy the rest of your evening, everybody. And remember that this video is saved to YouTube. That means you could go back to it and revisit the ideas just the same.
Okay, sir. Thank you.
All right, guys. I'll see you.